Hello, and welcome to Graphing Quadratics in Vertex form. This is an intermediate algebra look at it, so we're going to take kind of a basic approach to it, which will get more challenging depending on the level of the video. Okay, here we go. Definition: the vertex of a quadratic equation in vertex form can be read directly from the equation, and that's why we call it the vertex form. So if f of x equals a times x minus h all squared plus k, then the vertex is at the point hk. Notice that in this form, the h is being subtracted from x. Therefore, the x-coordinate of the vertex has the opposite sign of whatever you see in the formula. The k on the outside, we just use the sign of whatever k has. Okay, now these constants a, h, and k, they tell you something about the graph of f. First of all, if a is positive, this parabola opens up. Let me see here. I forgot to put in my draw here. If a is positive, the parabola opens up. And it could be anywhere on our axis system. Maybe over here, maybe somewhere else. If a is less than 0, the parabola opens down. Maybe it opens down like that. I remember it as positive people smile, right? Positive sign opens up. It looks like a smiley face. Negative people frown. Frown goes down. Whatever works for you, works for you. Usually it's the most ridiculous that keep it in your mind. So now if we ignore the sign, right, we've already taken care of the sign and opening up or down. If a is bigger than 1, the graph is narrower. So it's like we take this y equals x squared graph. Let's pretend I drew that well. And if I put a number bigger than 1 in front of it, maybe 3x squared, that means my y values are getting bigger 3 times as fast. So I'm pulling on these edges here and I'm pulling it up by a factor of 3. So it's narrower. Whereas if I have a graph over here of y equals x squared, and I make an a value less than 1, maybe 1/2 x squared, well, now this graph is going to be wider. It's like you're pushing down on the ends, making it wider. The h value tells us if the graph shifts left or right. If h is greater than 0, we'll have x minus h, and the graph shifts right. Okay, so keep in mind x minus h shifts right. If h is less than 0, we'll have x minus a negative value, so that's x plus. Anytime we have x plus, the graph will shift left. Now notice this is opposite of common sense. We see a minus sign, we're thinking it's to the left. But that's opposite. All right, so x minus h, the graph shifts right. X plus h, the graph shifts left. The value of k tells us if the graph is shifted up or down. If k is positive, it goes up. If k is negative, it goes down. So on the outside, it makes sense. If I add, I go up. If I subtract, I go down. But on the inside of the parentheses, before you square it, if you do it inside, it kind of is opposite of what common sense tells you it should be. That's all right. We'll work on it a little bit. The fact is that the domain of every quadratic function consists of all real numbers. I could give you this question 1,000 times and it's never going to change. I could write down a million different quadratics. I couldn't, actually. My hand had hurt. Whether I was typing or writing, but the domain of every single one of them will be all real numbers. The range of the quadratic depends on the vertex and the leading coefficient. Now, because the range is all about the y values, right? If a is positive, the graph opens up, and so the range will be facing up. Y is greater than or equal to k, or in interval form from k to infinity. Hard bracket on the k because we do equal that vertex point. If a is less than 0, the graph will open down. So the range is y is less than or equal to k, right? Down, less than, negative, we'll have a less than or equal to in our range. Greater than 0, greater than k. They match up very well. And of course the interval notation using the square brackets as I call them, on K because we do include it, and the round brackets, also known as parentheses, on the infinities, as we never actually touch them. Okay, so let's use this graph to answer some questions, see what we have here in dealing with quadratics. First of all, which point is the vertex? And this one's kind of nice because it's labeled for us. Negative 1.5, comma 3 is the vertex. Now, the axis of symmetry. The axis of symmetry is, if I were to put a little mirror in here, and it's always going to be a vertical mirror. If I were to put this vertical mirror in here, the left side of that mirror and the right side of that mirror should be equal. And we call this the axis of symmetry, and it's always an x equals equation because it's a vertical line, always goes through the vertex, so it's always x equals whatever the x coordinate of the vertex is. Okay, so now what point is symmetric to negative 3.5? See, negative 3, negative 3.5, comma 1. Our symmetry is what point is exactly the same distance away. That's what the line of symmetry, or the axis of symmetry, does for us. So what is this point? This point looks like the point 0.5, comma 1. Well, we're going to use estimates, but with this marked here as a 0.5, I'm thinking it should be assumed to be 0.5. Maybe my little circle got a little out of control there. All right, let's do it again. For example number 2, what point is the vertex? The vertex is up here at 6, 6. Again, it's labeled. What is the equation of the axis of symmetry? Our little mirror that forms through the center of the parabola, through the vertex, cutting it in half. Always an x equals equation, always the x coordinate of the vertex. Would the value of a be positive or negative? So since the graph opens down, we would have a negative a as, I don't know why I spelled as backwards, which is kind of funny. Negative a as the graph opens down. Okay, so how do I know the graph opens down? Is it positive or negative? So make sure you follow that up with an answer. In vertex form, what are the values of h and k? Well, we know that h equals 6 and k equals 6. So maybe I would choose to write this down in vertex form as f of x equals, I don't know what the a is for sure. I know it's negative, but that's it. X minus 6 squared plus 6. And what point is symmetric to the point 9, negative 3? Here's 9, negative 3. The exact same distance away. On the other side of the parabola is the point, it looks like it's 3, negative 3. Something else to notice here. We have x equals 6 as our vertex. Notice that the given point is at 9, negative 3, and the point we just found is at 3. What's right in the middle of those? 6 is right in the middle of those. So if we know the vertex and we know a point, we automatically can find the symmetric x value, and the symmetric y value for a given point will always be the exact same y value. They'll have the same height. So little cheaters rules going on there for you. All right, now, not very often are we given a function and its graph and then told to answer a few questions there, right? Where a lot of times we have to graph it ourselves. So to graph a quadratic function in vertex form, first we're going to look at a and determine whether the graph opens up or down. Then we'll find the vertex and the equation for the axis of symmetry. Then we'll find the vertical intercept by evaluating f of 0. Then we'll find an extra point by doubling the x-coordinate of the vertex and using the y-coordinate of the y-intercept. And I'll show you why that works out. 2h times f of 0, or comma f of 0. and then plot any extra points as needed, but you'll find that these are generally the only 3 points we need. Label the vertex, vertical intercept, and at least one additional symmetric point. State the domain and range. Okay, so I'm looking here, and I see that A equals 1 because it's not written, which is positive, so I know my graph opens up. My second step. I can see that my vertex is at the point 4, 3. It's always opposite sign of what you see inside the parentheses, x minus 4. So you get 4. The plus 3 on the outside stays the same. A lot of times I'll find the axis of symmetry, AOS, first. We take what's in this parenthesis right here. When you're in vertex form, axis of symmetry, set x minus 4 equal to 0. We get x equals 4. This is the axis of symmetry, but it also leads us to this vertex number of 4. So if you forget, find your axis of symmetry first, and you should it should be a little bit easier. All right, so a vertex of 4, 3, the graph opens up. I don't need much down there. One, 2, 3, 4, up to 8. 1, 2, 3. So I have a vertex at 4, 3. It should have been in blue. Let me just overwrite that in blue. I have an axis of symmetry, which we very rarely graph. I'm actually just putting it in here so we can see it. I can use it. And then a symmetric point. Let me see. What do I know here? Well, let's take this point, x equals 2. When x equals 2, f of 2 is equal to, yes indeed, yes indeed. I just went back and read my instructions. And for that reason, rather than edit the video, I'm going to leave it in there because you guys need to remember, sometimes professors forget to read instructions too. We have to find the vertical intercept. Since we have to find the vertical intercept, we have to evaluate f of 0. This is 0 minus 4 all squared plus 3. 0 minus 4 is negative 4. Negative 4 squared, who am I kidding? I'm actually recording this early in the morning. There's no way my brain is going to function correctly. So I'm going to put it in exactly as I see it into my calculator, and we'll get 19. Oh my goodness. So I'm going to do this little thing here that indicates a break in the action. And here we are at 19. 1, 2, 3, and some stuff, and we go up to 19. So we know that we are 4 units away from the vertical intercept on the left. Now this whole idea of 2h to find f of 0, we know h equals 4, so 2h equals 8. So here at 8, we will also have the point 8, 19. So we can see this axis of symmetry. We have 4 units to one side, 4 units to the other side. They have the same height. So I can sketch my parabola as such. And I have a pretty good view of it. It's a little awkward, but you know, that's what we get sketching by hand. If I had graph paper or something down here, it might be a little easier. But overall, let me see, what do we have? And we need to finish up with some domain and range. Always a good idea to add, make sure you go back and read the instructions. The domain, always all real numbers. The range, since this graph opens up, it starts with our k value of 3 and continues forever up until infinity. All right, let me see if I can move this, as I hope I can, without destroying anything else. Ooh, yes. Okay, so again, a equals 1. It goes up. On my axis of symmetry looks at x plus 2, just what's inside the parentheses, set it equal to 0. I'll get x equals -2, which leads me to my vertex, -2, comma, -1. All right, so those three things just float. Those come out first step. So now I'm looking for my vertical intercept at 0. All right, let's do this one in our brain. I woke it up a little bit with the earlier one. 0 plus 2 is 2. 2 squared is 4. 4 minus 1 is 3. So I have the point 0, comma 3. But keep in mind, my x value is 2. If I double, it's -2. Don't let me get away with that. Vertex x coordinate is -2. If I double that, I'll have -4. Use the y value from the y-intercept, and I'll have a symmetric point. Let's draw this graph. Let's see how we did. -2, -1 for our vertex. 0, 3 for our vertical intercept, and -4, 3 for our symmetric point. And we can more or less draw the graph. If you're drawing it by hand, just make the point big enough, it's all good. And keep in mind, the domain for every quadratic function is all real numbers. Those are sloppy looking infinities. The range, since this graph opens up, it's going to start with the -1 from the vertex and continue upward. Okay, last problem of this type. And it doesn't look like it's in vertex form. Oh no, what are we going to do? But it actually is. We might rewrite this. -2 times x minus 0 squared plus 5. I had a professor in graduate school tell me the difference between a math student and a mathematician, becoming a mathematician, is in your ability to add or subtract 0, multiply by 1, raise to the power of 1. Lots of good things that we could do, dividing by 1 even. So this whole adding 0 to rewrite the form to fit our needs might be more helpful. A equals -2, so my graph faces down. This x is by itself, so when I do x minus 0 equals 0, I get x equals 0 for my axis of symmetry, which tells me my vertex is going to be at 0, 5. Fantastic. 0, 5 vertex. Yes, sorry, I got lost there. Now I need to find f of 0. All those zeros got me a little confused for a minute. But we can handle this. Put in a 0 for x, always, to find our y-intercept, our vertical intercept. 0 squared, make sure you do the order of operations. 0 squared is 0. 0 times -2 is 0. 0 plus 5 is 5. Hey, look at that. Our vertex is our y-intercept. So that's kind of a bummer, because as we're looking here to graph this, 0, 5, and it opens down. So we have to make sure we give plenty of room both above and below. 0, 5 is our vertex, but we don't move to the right, we don't move to the left. How do I know how wide to make this? When in doubt, if you need other points, because the vertex is the y-intercept, you cannot find these symmetric points in the same way, just evaluate. F of 1, pick any value. 1's pretty easy. 1 squared is 1. 1 times -2 is -2. -2 plus 5 is 3. So the point 1, 3 is on the graph, which tells me that the point -1, 3 is also on the graph, same distance away from the vertex, 1 unit away on the right, 1 unit away on the left. They'll have the same height And there's my graph. All right, that's it for graphing quadratics in Vertex form. Thank you for listening.